This video will cover difficult questions regarding the topic of integrating logarithmic functions. This integral question doesn't seem to have anything to do with use substitution or logarithmic functions, but when you do integration, you will see that both are used. Shall we give it a try? Let u equal 1 plus square root of x. There are two ways to find du here. Let's do the method we used first. du equals square root of x prime equals x to the power of 1 over 2 prime equals 1 over 2 down x to the power of 1 over 2 minus 1 equals 1 over 2 x to the power of minus 1 over 2. Then we can rewrite as 1 over 2 square root of x. Then back to the original, 1 over 2 square root of x, then dx. There is only dx times 2 square root of x on each side, then 2 square root of x du equals dx. The left-hand side is respect to u. We have to change x with u. So minus 1 on each side, then u minus 1 equals cancelled square root of x. Then finally 2 times square root of x equals u minus 1 du equals dx. Now keep this one, then think about another way. U equals 1 plus square root of x, then minus 1 on each side, u minus 1 equals square root of x. To differentiate both, we must also differentiate square root of x. So first, we square both sides to simplify the expression. Then u minus 1 squared equals square root of x squared, which is x. Then derive on each side 2 u minus 1 du equals dx. We have the same result. You can use what is comfortable for you. Back to the original. Let's change all x into u. The integral of 1 dx is 2 u minus 1 du over 1 plus the square root of x is u equals the integral of 2 moves here, make separate 1 minus 1 over u, then du equals 2 times 1 du is u minus ln absolute value of u plus c. Then equals 2 u was 1 plus the square root of x minus ln absolute value of 1 plus the square root of x plus c. In here, square root of x is always greater than or equal to 0. So 1 plus the square root of x is always greater than 0. Then we can rewrite as 2 times 1 plus the square root of x minus ln, the bracket, 1 plus the square root of x plus c, not the absolute value sign. Number 2, let u equal cube root of x plus 2, then minus 2 on each side, u minus 2 equals cube root of x, then u minus 2 cubed equals x, derive on each side, 3 times u minus 2 squared du equals dx. Now replace all x with u. The integral of the numerator is u minus 2 over the denominator is u, then dx equals 3 times u minus 2 squared du. we can rewrite as 3 times the integral of u minus 2 cubed over u du. Use the binomial theorem. A minus b cubed equals a cubed minus 3 times a squared b plus 3 times ab squared minus b cubed. Now a part is u, b part is 2. Then u minus 2 cubed equals u cubed minus 3 times u squared times 2 plus 3 times u times 2 squared minus 2 cubed equals u cubed minus 3 times 2 is 6 u squared plus 3 times 4 is 12u minus 8. Then back to the original. 3 times the integral of u cubed minus 6u squared plus 12u minus 8 over u du equals 3 times the integral of, make separate, u squared minus 6u plus 12 minus 8 over u du. Now shall we integrate one by one? 3 times u cubed over 3 minus 6 times u squared over 2 plus 12u minus 8 times ln absolute value of u plus c. Then expand u cubed minus 2 times 1, 2 times 3, then 3 times 3 is 9, u squared plus 36u minus 24, and then absolute value of u plus c. The final answer is u was cube root x plus 2, then cube root x plus 2 cubed minus 9 times cube root x plus 2 squared plus 36 cube root x plus 2 minus 24, and then absolute value of cube root x plus 2 plus c. Number 3, let u equal e to the power of x plus 1. Derive on each side du equals e to the power of x dx. Then minus 1 is left over. Try separately. The integral of e to the power of x over e to the power of x plus 1 dx minus the integral of 1 over e to the power of x plus 1 dx. The first one, e to the power of x dx, is du. The integral of e to the power of x plus 1 is u minus the integral of 1 over e to the power of x plus 1 dx. While we are organizing the second integration, we have to keep the first one that has already been sorted out. So I will just write the second one separately. The integral of 1 over e to the power of x plus 1 dx equals the integral of 1, then plus e to the power of x minus e to the power of x. This is equivalent to adding 0, then over e to the power of x plus 1 dx. Now write separately the integral of this part is 1 minus this part e to the power of x over e to the power of x plus 1 dx equals integral of 1 dx minus the integral of e to the power of x over e to the power of x plus 1 dx equals x minus e to the power of x dx equals du over e to the power of x plus 1 equals u, then x minus ln absolute value of u plus c. Then back to the original. At an absolute value of u minus, this whole thing is here, x minus, at an absolute value of u plus c equals, at an absolute value of u expand, minus x plus at an absolute value of u plus c equals, this one and this one combined together to ln absolute value of u minus x plus c equals to ln u was e to the power of x plus 1 minus x plus c equals to ln e to the power of x plus 1 is always positive. We don't need the absolute value sign, just bracket e to the power of x plus 1 minus x plus c. If you remember this integral method, you can go to the original question similar to this and use the method we just used. Number 4, let u equal square root of x minus 2, then plus 2 on each side, u plus 2 equals square root of x, then square on each side, u plus 2 squared equals x, then derive 2 times u plus 2 du equals dx. Now replace all x with u. The integral of the numerator is u plus 2 over the denominator is u. Then dx is 2 times u plus 2 du equals to the integral of u plus 2 squared over u du equals to the integral of, expand the numerator, u squared plus 4u plus 4 over u du, then make separate u plus 4 over u, then du equals 2 times, integrate one by one, use the power for integration, u squared over 2 plus 4u plus 4 at an absolute value of u plus c, then expand u squared plus 8u plus 8 at an absolute value of u plus c. Now u was square root of x minus 2, square root of x minus 2 squared plus 8 times square root of x minus 2 plus 8 times ln absolute value of square root of x minus 2 plus c. Now use the binomial squared formula. A minus b squared equals a squared minus 2ab plus b squared. So square root of x squared minus 2 square root of x times 2 plus 2 squared plus expand 8 square root of x minus 16 plus 8 at an absolute value of square root of x minus 2 plus c equals x minus 4 square root of x plus 4 plus 8 square root of x minus 16 plus 8 at an absolute value of square root of x minus 2 plus c. Then we can simplify x minus 4 square root of x plus 8 square root of x plus 4 square root of x. Then 4 and minus 16 is minus 12 plus 8 at an absolute value of square root of x minus 2 plus c. We already have a constant term c. But here is another constant minus 12. Since we don't need to write them separately, we'll just group them into one constant term. Since we don't know the value of c from the start, we can just think of it as an arbitrary constant c, regardless of whether we add or subtract 12. In order to make the last answer c, I will change all part written in c to c1, like this. The final answer is x plus 4 square root of x plus 8 at an absolute value of square root of x minus 2 plus c, where minus 12 plus c1 bc. Number 5, let u equal x plus 2, then du equals dx. From here, minus 2 on each side, u minus 2 equals x, and then minus 1 on each side again, u minus 3 equals x minus 1. Change all x into u. The integral of x is u minus 2, x minus 1 is u minus 3 over x plus 2 is u cubed, then dx is du, equals the integral of, expand the numerator, u squared minus 3u minus 2u combined together minus 5u plus 6 over u cubed, then du. Then make separate 1 over u minus 5 over u squared plus 6 over u cubed, then du, equals integral of 1 over u minus, make a power form, 5 e to the power of minus 2 plus 6 times e to the power of minus 3, then du, equals, at an absolute value of u minus 5, now use the power for integration, e to the power of minus 1 over minus 1 plus 6 times e to the power of minus 2 over minus 2 plus c, equals, at an absolute value of u, make positive 5 over u minus 2 times 1, 2 times 3 over u squared plus c. Then back to the original value x. At an absolute value, u was x plus 2 plus 5 over x plus 2 minus 3 over x plus 2 squared plus c. This is the last one. F prime of x equals the integral of f second prime of x dx equals the integral of 1 over x minus 2 squared plus 6x dx, equals, make the power form, x minus 2 to the power of minus 2 plus 6x dx, equals, when you integrate x minus 2 to the power of minus 2, we don't need to use u substitution because the coefficient of x is 1, so just to think of it as x. X minus 2 to the power of minus 1 over minus 1 plus 6 times x squared over 2 plus c, then minus 1 over x minus 2 plus 2 times 1, 2 times 3, 3x squared plus c. Then f prime over 3 equals 20. F prime over 3 equals minus 1 over x is 3, then 3 minus 2 is 1, plus 3 times 3 squared plus c. F prime of 3 equals 20 equals minus 1 plus 9 times 3 is 27 plus c. Then 20 equals 26 plus c. Then c equals minus 6. So f prime of x equals minus 1 over x minus 2 plus 3x squared plus c, which is minus 6. Now f of x equals the integral of f prime of x dx equals the integral of f prime of x equals minus 1 over x minus 2 plus 3x squared minus 6 dx equals minus ln the absolute value of x minus 2 plus 3 times x cubed over 3 minus 6x plus c1 equals minus ln absolute value of x minus 2 plus cancelled x cubed minus 6x plus c1. We can use the letter c again because the two constant terms here aren't always the same number. Now use f of 3 equals 7, then f of 3 equals minus ln absolute value of 3 minus 2 is 1 plus 3 cubed minus 6 times 3 plus c1. F of 3 is 7, then 7 equals ln 1 is 0, 27 minus 18 plus c1, then 7 equals 9 plus c1, then c1 equals minus 2. The final answer, f of x equals minus ln absolute value of x minus 2, but x is greater than 2, so we don't need absolute value sign, just bracket x minus 2 plus x cubed minus 6x plus c1, which is minus 2. I hope this video has been helpful. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.